assuming that pretty much assuming that everybody there is about ready to go on spring break. Those who are not already on spring break, by the way, is there anybody there? Is there anyone in the class at all today? Hello? Hello? No? Okay, all right, well. We're going to do this anywho, and what we're going to do is wrap up the airspace section. We're going to go through flight planning, and then we are going to be ready as soon as you guys get back from spring break. We will have a quiz, not as soon as you get back from spring break. You don't have school on Monday following spring break. We'll have a kind of a quick review on Tuesday with regard to airspace and flight planning. There will be a quiz on Wednesday, and we will get then into the instrument work to kind of wrap us up through April, okay? And then, as soon as we are done there at the end of April, it is going to be test prep. Test prep for the private pilot, test prep for the instrument rating, and by mid-May, we are going to begin that trip back and forth between Aspen and Grand Junction to get you all tested, all right? So just keep that in mind. Then once we get everybody tested, the balance of the year is going to be on some pretty cool stuff. We'll be doing stuff again, more stuff with the simulators. By the way, you guys will be doing more stuff with the simulators in April. More stuff with the simulators kind of at that end of that last 2 to 3 weeks of class when we do that. And in addition to that, we're going to be doing some of the NTSB stuff where we'll be looking at aircraft accidents, and we'll be sitting there and we'll be reviewing these things, and you all are going to shake your heads and you're going to go, how could anybody be so stupid? Yet we still seem to, as humans, seem to figure out how to let a perfectly good airplane fall helplessly out of the sky. So with that, guys, what we're going to do is we're going to get crack-a-lackin' back here into the airspace. So with that, I want to show you one thing here real quick before we do. This is a little view right here. Any of this look familiar to you? Yes. By the way, as you look there, and my guess is that by the time that you guys see this, the weather is already going to be probably upon you. And so here, we look here again, here's Aspen. That blue segmented circle indicates what kind of airspace? Yes. And then as we move a little bit further east, here's Denver. Take a look at this. What kind of airspace are we looking at there? Let's go down here to Colorado Springs. What kind of airspace are we looking at here? It doesn't look like any kind of a upside down wedding cake I'm familiar with. Well, unless there was some sort of a mishap getting from the catering truck to the presentation table at the blessed event. So you'll have to look at the Class Charlie airspace there. We look down here at Pueblo. See, where's Pueblo? Here's Pueblo. So we look down here at Pueblo, and we can see that we have what kind of airspace? This is a little tricky, because when you look here, you can see that not only do you have airspace in a blue segmented circle, you also have a VOR compass rose there just east of that, and then beyond that, you have some special airspace there with that magenta looking segmented circle out there. There's a big thing there that says notice. And guys, if I could give you just one little piece of advice, is that as you do your review on special airspaces and special use airspaces, not just that, but restricted and prohibited airspaces, and you guys can see that. I don't have to read for you. You have certainly read the text. And understand that that there are some airspaces there that can be particularly problematic if you do not have, first of all, kind of that wandering flight planning thing, and we're going to look at that. And they kind of have a tendency to just not be real tolerant to people sort of flying through their airspace. And what I'm going to do is give you a quick example of that and give you one of these little anecdotes here as well. So here we go. Where's this? Good. All right, that is Albuquerque, New Mexico, and you can see there's Class Charlie airspace. You'll see the compass rose of a VOR or a VORTAC just to the west. To the northwest of that, you'll see a little place called Double Eagle Airport, KAEG, and that is where that's where that first school that I started still exists, I am thrilled to say. So as we go north of Albuquerque and kind of east a bit, you'll see Santa Fe. Just north and northwest of Santa Fe, you will see something called Los Alamos. Any history fans out there? Any World War II kind of history fans? Any nuclear area fans, not necessarily fans, but you know, history, at least awareness there about the importance of Los Alamos with that. Los Alamos sits, if you look here at the terrain, and let me go ahead and take this, I'm going to get the weather off this here for now so you can see this. If you look here, you can see that north of Santa Fe is a big valley, and to the west, to the east, there is terrain. So you have this valley, and this valley is a pretty good corridor for VFR travel heading north and south of there. You can also see the Victor Airway that's there, Victor 83, that kind of runs up there north and south there also. I was coming back from Alamosa. Alamosa, by the way, is up here. No, that's San Luis Valley. Alamosa's over. Yeah, I'm sorry. Yeah, so there's Alamosa. Alamosa's down there in the this San Juan Valley, San Luis Valley, I'm sorry. And then as you just kind of go down, there's Taos. And then here, by the way, as you look here on this, I was going to try to show this to you. San Antonio Mountain right there, you can see that that's 10,900 feet. That 10,900 feet, that is the world's tallest, I believe is what the big sign says there, pure volcanic, not the world's tallest, but in the lower 48, it is the tallest volcanic mountain that exists here in the lower 48. At least that's my recollection of what that sign says. I don't know. I'm old and I forget things. So there's the Taos Vortex there. And coming right on down inside this valley, I was coming back from the San Luis Valley, or Alamosa, and there was some weather just off to the east. So it pushed me to the west side of that valley. And in fact, there's one of the Indian airports there, and it pushed me over into that airspace just east of Los Alamos. Now, that's restricted airspace there. You can see kind of why that is. Los Alamos is kind of an interesting little airport. It is a one-way in, one-way out airport as well. But that airspace around there, they are pretty doggone particular about who is there over that airspace, especially after 9/11. You got awfully popular when you were over there near that. As I was flying south, trying to get back to Double Eagle Airport, I had Albuquerque Center. I had them all over me, making sure that I knew exactly where I was and to make sure that I was not going to encroach on that airspace. And it is one of those areas where you just don't want to roam, because there are a few places in this country where if you are not careful, they may shoot. So that's one of those spots. So just kind of letting you know. And you can do the reading on the restricted airspace there as well. Let's go back up here to Aspen. So yeah, I'm guessing that by now you all are getting rain, if not snow, at this point. So you know, there's that. Now, back to the airspace. So you can see that we talked about this, and you can see that the different types of airspace. We covered Alpha, Bravo, Charlie, Delta, and now Echo. Echo is probably, with the exception of the Class Alpha airspace, the second largest airspace that we have. And it is kind of, you think of E as sort of like everywhere. So is kind of how you do this. And when you read here about Class Echo Airspace, I'm going to just, let me move this here, sorry. Okay. One of the things that I wanted to show you here on the map here is that a great place to begin working on your airspace knowledge, I thought I turned that off, I turned it back on, sorry. On your airspace knowledge is going to be on your sectional maps. So like you see here, you can see these shaded vignettes. Where do you find the answers as to where that stuff is? You can look on the legends of your sectional maps. You can also look on that airspace guide that you downloaded from the FAA. And I want you guys to go through all of that airspace piece and understand what your elevation restrictions are with this, where it is, where it isn't. Also in the West, there is also some interesting airspace. Let me take you to New Mexico, because that's kind of where I know that some of this exists. Well, I say I know where it exists. Stand by. Down here. So, for instance, as you head down the mighty Rio Grande toward El Paso, this is just south of Albuquerque. There's Albuquerque, and as you follow the river down, you can see that you're following a corridor here that includes some pretty nutty airspace. So you've got to know about where that stuff is, because it's, yeah, you can get popular real quick down there. You can see there just right there in the Magdalenas, just west of the Socorro Airport there, that you also have some restricted airspace. The Very Large Array is wandering around down there. I'm trying to remember where that is. It's somewhere down there. Shoot, I'm trying to remember. I'll have to find it because it's kind of a cool thing. But they don't want you anywhere over that, because that's where they're listening to ET. So you kind of got to watch that. Heading down the airspace here, you can sort of see that you have terrain there to the west, and then you have our nation's finest out there in those fighter aircraft out there playing in all of these restricted areas, and that's just not a place that you want to find yourself. So this is why you can see that these Victor Airways through here. So for instance, if you look and you can kind of see the Victor Airways moving through, these are going to be places that you really want to stay if you can, because those will keep you out of trouble. But then how do you know if an MOA is hot? So for instance, over here, you've got the Cato MOA, the Smitty MOA. They all have altitude and speed restrictions that they have running through there as well. And with these things, there also comes not just necessarily an opportunity to kind of cut the corner somewhere if you can, but you need to know if those areas are actually hot. What does that mean? What that means is that these guys are actually out there practicing. And so when they're out there practicing, what that means is that they're intercepting, shooting, bombing, all that kind of stuff, and just not really things that civilian pilots need to be too close to. You feel me? So these are things that you guys need to check before you go. How do you do that? We're going to talk about that here in just a minute. So understand what the difference is between a prohibited area and a restricted area. Understand here, oh, I'm sorry. I was on Class Echo Airspace. I got ahead of myself. Forgive me. In the Class Echo airspace, it's like underneath the Class Alpha airspace, it's the largest controlled airspace that there is beyond Class Alpha. And your sectional maps, you'll be able to see where those are, kind of where it begins. In most places, the Class Echo airspace will begin, the floor of that will be about 1200 AGL, but there are some places where Class Echo airspace, it can either be the surface or it can be 700 feet AGL. And those shaded vignettes will tell you where all of that is. So you can look on the legends and determine what is what. So I want you guys to play with those and find those out. If you have questions, what I want you to do is I want you to write those questions down, email me, or save them for me for Tuesday when you guys get back from spring break, and we're going to knock that out. Uncontrolled airspace. Uncontrolled airspace, what does that mean? Does that mean that it's just like, you know, just a free-for-all? Well, the type of class Gulf airspace, it exists, I'm told, primarily because we still have a segment of our flying public that they fly low to the ground. They don't necessarily use radios, which just still boggles my little mind. Is that how is it in this day and age that somebody can get up there and flog around our nation's airspace without a radio at least? And you know, there's places where you don't have to have one. Places where there's some guys that they just don't want a radio. Well, all right, just know that they exist. So the class Gulf airspace is a little bit different. So I want to go back here to this and I want to show you where this is. So this class Gulf airspace exists where all the other airspace doesn't, from the surface to 1,200 feet AGL. Now I'm going to show you something here. So if we look here at some of the airspace that we have, and it says that that the airspace, you know, is going to be 1,200 feet AGL. Well, let's look at some of this. If we look at some of these places in Colorado where the airspace is 1,200 feet AGL, give me just a second here, stand by. Let's look right here. There's Mount Elbert. So we can see that the top of class Gulf airspace on the other illustration, they show that as being 14,500 feet. However, there are places in our neck of the woods where class Gulf airspace actually exists higher than that AGL. Because if you add 1,200 feet to 14,433 feet, you can see that that puts you up there at 15,633 feet. That is still Gulf airspace with that. So you kind of have to know that there are some of these mountain ridge runners up there that are still in class Gulf airspace that don't have to have a radio. They don't have to talk to anybody. Why is this important for us? Because what are we doing when we're flying in and out of some of these canyons here? We're trying to do it, you know, what I call the right way. Understand that there's a legal way to do this here as well. You've got to be vigilant. You have to be able to see these guys. It's why this traffic piece is so important. It's why we run with our lights on when we're down there and we're doing some of this low mountain flying, is because we want to be able to see who's out there. So you've just got to be careful to understand that you can have areas on some of these mountain passes that you guys are going to be flying through that you could well be in class Gulf airspace. So you have to be watching for who's where, okay? All right, now, yes, back to this. All right. So you've got the different classes of airspace. You have special use airspace, and you also have, if you'll remember, those VFR weather minimums. This is the piece here that we were talking about here. So to understand what your VFR weather minimums are, let's look at this one more time. Below 10,000 feet MSL, Bravo, Charlie, Delta, Echo airspace. Is that your minimum VFR clearance here is going to be 521 with 3. 521 with 3. What that means is you must stay at least 500 feet away from the bottom of a cloud, 2,000 feet horizontal, 1,000 feet above, with 3 statute miles visibility. Do you think the FAA might pose a question to you here with visibility in nautical miles that looks a little tempting? Don't take it. Statute. Okay? Then in that class Gulf airspace during the day, The visibility minimums, they actually get a little bit lower. So your visibility goes to 1 statute mile visibility, but you still must remain 500 feet below, 2,000 feet horizontal, and 1,000 feet above a cloud. Unless you're 1,200 feet AGL and below, and so with that, it is going to be 1 statute mile and clear of clouds. Clear of clouds. You'll also note that you wrote down this little asterisk here beside the letter B for Class Bravo airspace. Class Bravo airspace, you need 3 statute miles of visibility, but it says you must remain clear of clouds. What does that mean? That means that you can get closer to a cloud. You just can't enter one. So you can get inside that 2,000 feet horizontal, inside that 500 feet below, and inside that 1,000 feet above, as long as you don't enter the cloud. Again, we're talking VFR weather minimums here, okay? Clear of clouds, okay? We also know that at night, Class Golf airspace reverts back to everything else here for Bravo, Charlie, Delta, and Echo. Above 10,000 feet AGL, we do it a little bit differently, and this is going to be where you're going to find Class Echo and Class Golf airspace above 10,000 feet MSL. And that's going to be 5 statute miles visibility, so your visibility has to increase a bit, and it's going to be 1,000 feet below, a mile horizontal, and 1,000 feet above. Learning how to write or draw the VFR weather minimum, to me, this is far easier to remember than it is for the table about what your VFR stuff is. So I think Mr. Machado did a tremendous job coming up with this, and you know, God bless him. He's one of my heroes. So there's that. Now back to this. Also, as you go through here, pay special attention here to what your communications requirements are within this kind of airspace here, and also what your transponder requirements are for that kind of airspace. Whoops, hit that too much. Hold on. Yes, the TERSAs, there aren't very many terminal radar service areas around anymore. In fact, I think there's probably less than a handful across the country. But those are noted by a light gray circle around the airport there as well. Your legend will tell you about the operating requirements in the TERSAs. Victor Airways, we all know this, that the Victor Airways are going to be those little highways in the sky between ground-based radio navigation units, or VOR, and they are going to be 8 miles wide or 4 nautical miles either side of the center line. So understand what those are. The special use airspaces, you guys can read this, how they work, the MOAs. Military training routes, you'll see this also on your sectional maps. You will see training routes. I was going to go down into New Mexico, and let me see if I can find you a couple of these training routes. Stand by. I thought I had a place here where I had several of them kind of all together. Give me just a second here, guys. I'm sorry. That's Cannon. I want to go down here to Holloman. Yep, hang on. Okay, so here, this is near Holloman Air Force Base. So you can see right here, excuse me, that you can see here that you have instrument flight rules this is for the military. So these are military training routes, and you'll see IR here in front of these. All of them have kind of special requirements inside those routes there as well. There's a VR. So you can see these gray lines here. So those are going to be the visual flight rules or visual rules for the military here. The IR, those are going to be the instrument rules through here. So that's kind of what those look like. And then we have temporary flight restrictions. Let's say, for instance, in fact, let me pop this up and let's see if we have any TFRs out here in this great land of ours. And in fact, we do. So here we go. This is over here in Gallup, New Mexico. In Gallup right here, you can see that red circle right there, that is going to be a TFR, okay? So if you can look right here, ZAB means that this is where the, hang on, I'm going to blow that up a little bit. ZAB, that is the Albuquerque Center for Air Traffic Control. And so what this will tell you here on ForeFlight is that it will not only show you where these TFRs are, they update these TFRs. You can see that right now in this, you can see that it's inactive at this point, and it goes from the surface to 11,000 feet. And then inside that box, it'll tell you in some cases why it's out there. We start to see a lot of these TFRs pop up out here, starting kind of in the early spring into the summer because of fires. And so you'll see a lot of TFRs pop up that way. Let me see what other kind of TFRs we've got over here. Some of them are just, they're no longer a temporary flight restriction, they're almost a permanent flight restriction. So if you see here, you know, for stadiums, anytime that there's like a big sporting event, they'll put a temporary flight restriction to that to try to keep people out of that area. And then also over here, here's another TFR. This is part of Disneyland. And so it's like it's not temporary, it's pretty much a permanent flight restriction because they have tried to limit the areas here. Here's another one, stand by. This one, high-speed aerial demonstrations. That's always fun, especially like you get the Blue Angels or you get the Thunderbirds out there. It's pretty cool. So they restrict those areas and those TFRs to keep people away from large congregations of people, and they really got aggressive with this after 9/11, as you might expect. Airport advisory areas, you guys can read those. Here again, this is Mr. Machado's VFR weather triangle in tabular form. And I ask you, which would you rather learn? So you can look at this as well. If that makes more sense to you, God bless. And then, fini. So look at your airspace in big blue and big red to make sure that you understand all the airspace questions and requirements. Flight planning. In the next 13 minutes, we're going to talk about flight planning. This is the piece that you guys can read. And what I want to do is I want to go through this, and then I want to visit with you about the practical application of flight planning here as well. It'll go through some of the personal navigation equipment. This is what we refer to in the biz as building your nest. Do you have everything within reach? Everything that you need to operate your aircraft safely in our nation's highways and byways, where you can get a hold of everything that you need. That cockpit organization piece is huge. And having learned that the hard way, it's a thing that you just really kind of become zealous about when you set up your cockpit system so that everything is here, everything is organized. You don't even have to look to find your stuff. In fact, my flight bag sits behind the co-pilot seat right here, unless I have a passenger there, and then they're responsible for pulling anything I need out of my flight bag. But I can reach over here into my flight bag and I can pull anything out of there that I need without looking, because I just know where I put everything here. And it's a good exercise. Oh, by the way, that's another thing that we're going to be doing the last couple weeks of class after we do our testing in Grand Junction is anatomy of a flight bag. I thought you might just kind of like that. So that's kind of what you need here. Again, we start thinking in terms of our flight planning. We sort of begin with the weather. We keep a rolling 5-day local forecast in our heads as we do this. A little bit longer if we're talking about a longer cross-country flight of, say, 1,000 miles between New Orleans and Aspen. I mean, just, hypothetically. And so We always want to make sure that we look at the weather. We always want to make sure that we check the NOTAMs and the TFRs. We always want to check that. And the best way to do this, guys, is 1-800-WX-BRIEF. 1-800-WX-BRIEF. One of the things that we will do on Tuesday is we will actually call the flight planning folks there, and they are located in Prescott, Arizona. And we're going to call them, and we're going to actually go through a mock standard weather brief that we have for a fictitious flight somewhere. Okay, so we're going to do that, and we'll get them on the phone and actually make that happen. So again, your weather, you can see all of this here. Understanding your flight service stations where you can get information. Again, checking NOTAMs, checking your MOAs to make sure that the MOA is cold if you plan on transitioning through those. SIGMETs and AirMets. Understanding, you guys remember from the weather what a SIGMET is and an AirMet is. AirMet is one of those things that primarily focuses on us little guys. SIGMETs even apply to the big boys. And you've seen that through your weather, but those are things that we want to do. The go, no go decision, these are things here that from a VFR weather standpoint, it's pretty easy. I mean, if you're not right, if the airplane's not right, if the weather's not right, you're done. It's a no-go. In the instrument world, it's a little bit different. Now, I mean, clearly, if you're not right, if the airplane's not right, well, you're a no-go. However, let's just say that from a VFR standpoint, you're kind of socked in, and the weather service, or the flight planning place and in Prescott tells us about mountain obscuration along your route. Well, if there's mountain obscuration along your route in a VFR flight, you're a no-go. But in an instrument flight, you may be okay, but it depends. Because it depends on what's in that cloud. Is there the potential for icing? If the potential for icing exists in that cloud, then you're going to have to choose a different route, or you are a no-go. So, you can read about the go, no-go decisions there. The planning, you guys remember from the 5 Ps from way back, I think in chapter 1 or 2, the 5 Ps of the planning and how you start that. Doing a flight log. We will also look at a flight log on Tuesday when you return from spring break. Choosing your altitude, you'll remember this. Magnetic course VFR, WEO, west is even, east is odd, plus 500 feet. So that's how that is on a magnetic course. Magnetic course, not a heading, but a course. And you choose that altitude anytime you're operating more than 3,000 feet AGL. Measuring your courses and distance, we know how to do that with our plotters. Go us. This plotter that they're showing here in this particular illustration is what they call a super plotter. It is the plotter that I have in my flight bag, and it's really pretty slick. It's very, very fast because you can line up here your latitude or longitude with this, and then you rotate the long side of your plotter underneath it once you have it lined up, and it's pretty useful tool there in figure 19.4. We don't use them in the class. I had a few of them early on, and kids were breaking them. So I stopped spending 3 times the amount of money on those, and I started getting cheap ones. Y'all want a super plotter? Get it yourself. Distance. All pilots have various ways that they use to kind of determine distance on a sectional map when they're flying. In this case, they show an illustration of these little notches that they have carved into a pencil that they have there right there in their kneeboard or their flight bag. That's pretty slick. I kind of like that because not only does it help you with distance stuff, but sometimes, especially in warm weather, those pencils can get a little slimy. And it's a little easier to hold on to those with those little hash marks in there. Thought that was pretty good. Calculating time, speed, heading, we all know how to do that. Completing the flight log, we'll go through that as well. Fuel calculations, because remember, anytime that spinny thingy is spinny thingy-ing, we are on the clock. We have a finite amount of fuel to make that engine go. And so we have to plan on the amount of fuel that we need for a particular flight, including our reserves. There are certain fixed reserves that we have that are going to be defined by the regulations, but then we also have our personal minimums, and I have talked to you guys about that before. Weight and balance, done it. Takeoff and landing performance. These are going to be the things that we are also going to mop up with on Tuesday, calculating takeoff and landing performance that we have. And we'll show you how to do that on Tuesday. You guys can look at this and you guys can see. You just kind of understand that the big things with regards to takeoffs and landings are the things that we talked about in weight and balance and performance issues. A heavier airplane is going to require more runway. When it's hotter, you're going to require more runway. When you have the high density altitudes, it's going to require more runway. These are things that we have to think about when we're determining, is this airport going to work for us? Do I have enough room to work? That's kind of our big thing. We have to calculate our en route performance, again, to kind of manage that fuel thing. Cruise altitude, the cruise altitude power settings that we have. We have power setting charts. Those are things that are going to be in our POH or our AFM that that'll give us at least book values about what our airplane should do. Now, I will say this, is that when you look at these things, what you can see on this particular chart is that at a given pressure altitude, and again, also at a given temperature, which I don't see on here, is to say if it's a standard temperature, colder than standard, warmer than standard, you can look and you can see kind of what the categories that you're going to be looking at here with your pressure altitudes, etc., in your performance charts here for your particular aircraft. I don't know what a DR22 is. I can only imagine that that's a typo. I'm thinking it's got to be an SR22 Cirrus. So as you look here, you can see one of these predictive types of things. So if you have, let's go here to a little bit higher, 4,000 feet of pressure altitude. So if your PA is 4,000 feet and your temperature is below standard, or warmer than standard, you can look and at a particular power setting here, with a let's go a little bit lower RPM, manifold pressure here of 25.4 inches. This gives you basically kind of a power rating of about 87%. This should give you, in this particular airplane, in this case it's a Cirrus SR22, it'll give you a true airspeed of around 178 knots while burning 20.6 gallons per hour. Remember that this is a twin turbocharged engine, so the reason that it's burning that much fuel and that it can burn that much fuel is because it's twin turbocharged, so it's sucking in a lot of air. So if you look, what happens here is that the warmer here, as you look at this, you can kind of see what happens here when things get warmer versus standard versus colder. And we'll look at those things on Tuesday. These are going to be some of the things that we see here with regard to some of the power settings here within cruise. Again, we'll cover that on Tuesday, but read through this and understand what to do. Interpolation. So let's say here that we're looking at a pressure altitude. Here's 10,000 feet here, here's 12,000 feet here. Let's say that you're cruising on an IFR flight plan at 11,000 feet. Well, if you look over here at, let's say that this standard day where the temperatures are going to be about right, and you look at the difference between 10,000 feet and 12,000 feet, in this case, they're identical, 163 and 163 for the true airspeed here in knots. But on a warm day, you'll see that at 10,000 feet, you may be able to go a little faster. So here's 166 and here's 163 here for 12,000. So what would 11,000 be? Well, what's the difference between 166 and 163? It's 3. So you divide that, you take the difference, divide it in half to get this thing that's halfway between, which let's call it 11,000 feet, and that should give you the performance of approximately 164.5. Okay, that's kind of how you do the interpolation bit. Fuel consumption, again, we talked about how to do that. Effective wind, yep, got it correct for that. We've all done that. Flight planning form, I'll show you this here. This is a pretty useful form, and we'll talk about this here. We use a little different kind of form here for our flight planning with this, and I'll show you this here in just a second. Here we go. This is going to be the thing that we look at here. The little clock on the wall tells me that I have blown through my 40 minutes video here. Pay special attention here, guys, to this particular figure. What is it? Can't get to it. Figure 19.14. Figure 19.14. These are going to be the things that you'll see on a particular flight plan. And one of the things that you're going to need to know on this is that the FAA will ask you, so what information goes in box 4? What information will go in box 4? And in this case, you're going to need to know it's going to be your true airspeed. Okay? So that's going to be the thing that you look at. We'll talk about this on our flight planning thing here on Tuesday. Remember the documents that you have to have in your airplane: AERO, airworthiness, registration, operating handbook, and the specific weight and balance sheet for that particular airplane. Compass card, that's there, that's flight planning. Okay, so that wraps up the airspace, that wraps up the flight planning. We'll review that stuff on Tuesday, quiz on Wednesday, following your return to Aspen after your spring break. I hope everybody has a safe and happy spring break. Enjoy yourselves, go out there and have some fun, be safe, and I look forward to talking to you guys again here real soon. Okay, guys, have fun, and I'll talk to you soon. See ya.